Okay, pre-cal, we have arrived at our last application section of this unit. Woohoo! All right, so how do we use log function in application? Well, I'm going to show you 3 different ways we use it, and these should be familiar to you. The first one we're going to talk about is the Richter scale, and remember this is measurement of the magnitude of an earthquake, that we use the Richter scale to determine what the magnitude of an earthquake would be. So that formula is right here. So we're going to talk about that. And I want you to notice in the formula, it's just m of x equals log of x, where x is the seismographic reading. And then you've also got x naught in the denominator, and that is the 0 level reading. So essentially, all we have to do is know both of those, and we just find the log of it. It's totally easy. Easy peasy lemon squeezy. All right, the other thing we're going to talk about, or one of the other things, is the intensity level of sound, because we use the log function to measure our decibels, and that's how we measure the level of sound. So this is the formula for that, and we are going to look at taking 10 log of W, W being the intensity of the sound in watts per square meter, and then we are going to also look at W naught, which is the constant. It is a constant. That means it's going to be the same for all the problems we're going to do. So moving on here, we're also going to look at an application for the pH of a chemical solution. So the formula we have for pH is going to look just like this. We're going to have negative log times H plus, where H plus is the concentration of hydrogen ions in moles per liter. All right, so remember, if you remember this from science, great. If you don't, I'm going to talk about it. Remember that your values for pH range from 0 to 14. Okay, and 0 is on the acidic end, and then 14 is on the alkaline end. So the closer you are to 0, the more acidic the pH is going to be. All right, so let us go ahead and do these problems. You're gonna love it. All right, number 4 here for my example. If the intensity of the sound of a person's talking loudly is 3.16 times 10 to the negative 8 watts per square meter, what is the intensity level of the sound in decibels? Okay, so it's clear that we're using decibels here, so I'm going to go up and look at this formula right here. I'm going to be using the intensity level of sound formula. So I'm just going to write this down. It's 10 log, and then in the fraction, in the numerator, I am going to have this right here. So 3.16 times 10 to the negative 8 over this right here. I told you it was easy. Okay, so I don't know why I wrote a decimal there. 1.0 is the same thing as 1. So 1 times 10 to the negative 12. And this is all calculator work. Check this out. If you're going to use your Desmos calculator, I have my Desmos window open here. And you've got choices here. The graphing calculator is the one that we use for, graphing stuff. And this is the scientific calculator. This is what I have right here. So this is what's going to help me if I've got a log problem. So I'm going to start out by typing in the 10, all right, because I'm using my formula for intensity level of sound. And then I'm going to use this function key right here and choose log. Now you'll notice we've got a lot of stuff in the numerator, so I'm going to open up a set of parentheses, and I'm going to type in 3.16 times 10, and then my exponent here to the negative 8, and then I'm going to use my arrow to move down, close those parentheses, then divide by 1 times 10 exponential again, negative 12, and that is my answer, 44.9968, blah, 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 blah. Okay, so 44.997 is what I'm going to write. So 44.997, and this is an approximate value. So that's going to be the intensity level of sound in decibels. Awesome. See, I told you it was easy. All right, so if the threshold of hearing for a certain person with hearing loss is 5 decibels, will a sound with an intensity level of 2.1 times 10 to the negative 12th watts per square meter be audible to that person? So what we're going to do is find our value here. So I am just going to write it, sorry, over 1 times 10 to the negative 12. And of course, use my calculator again. I'm trying to save time on your video though. So I get 3.22. So will a sound with an intensity level that has this many decibels, will this person be able to hear it? Well, if their hearing loss is 5 decibels, okay, if that's their threshold, then they're not going to hear this because it's going to be too few decibels for them to hear. All right, so now let's go to number 5. Find the magnitude of an earthquake with this intensity and a minimum intensity of 1. All right, babies, so let's look up here at our Richter scale equation. Remember, the numerator is your seismographic reading, and the denominator is the 0 level reading. Okay, so that means the minimum, 0 level reading. So this is what this formula is going to look like. I'm going to take the log of this massive number over 1. Yes, it's that easy, kids. Okay, and all we have to do is come in here to our calculator, type in log, type in 80,500,000. Make sure I did that right. So 7.9 on the Richter scale. See, look at us. We're machines. Done and done. Okay, next, find the magnitude of an earthquake with a seismographic reading of that many millimeters. 100 kilometers from the center when x naught is 10 to the negative 3. So I'm telling you what that denominator would be. So I'm just going to find this like this. Easy peasy, lemon squeezy. So I go to function, I choose log, I choose this massive number again, divided by 10 to the negative 3. Awesome. Okay, see how easy this is? I knew you'd love it. So 8.1, I think that's what that said. Excellent. All right, last 2 questions. What is the pH of a solution for which the hydrogen is 0.0012? Okay, I'm using this equation right here, and I'm asking about the pH. So all I have to do here is write pH equal to negative log times that right there. See, could this get any easier, kids? I don't think so. So I've got negative log of 0.0012. Groovy. All right, so the answer is going to be, I didn't, 2.92. I should have said it out loud. 2.92 is going to be the pH if the hydrogen is 0.0012. All right, this one determined the hydrogen ion concentration of an orange with pH 3.5. So this time we're using that same formula, but this time we're finding the hydrogen instead of the pH. So I'm just going to substitute 3.5 in here. And then I am going to divide both sides by -1. So that gives me negative 3.5. Okay, now all of these formulas we're using, you'll notice I haven't drawn in a base. That's because the base is 10, because these are common logs. So I'm going to have to rewrite this in exponential form. So it's going to be, remember, base 10 to the negative 3.5 will equal my hydrogen ion concentration. So all I need to do is go back to my handy dandy calculator, type in 10 up to the negative 3.5 power, and bam, 3.16 times 10 to the negative fourth. That is just scientific notation. It just means that there are 3 zeros essentially in front of this. So you could write it this way, 1, 2, 3. Okay, because that -4 means moving the decimal over 4 places. Okay, so you can write it this way or you can write it this way, whatever floats your boat.